Now we're going to talk about how to identify how many sig figs or how many places a given number has. And when I say given number, I don't mean you're measuring it and you have to decide how many you should write it out with. I mean, if someone gives you a number, you should be able to look at that number and decide how many sig figs it has. First, let's discuss why we even care about this. Why do we do this? There's a very good reason for it. When we write out numbers in math and we write out a quantity, we always think that that number is exactly what we see. However, when we take measurements in a lab, it's a little bit different. Let me give you an example. Let's say we're weighing an object, okay, and I'm using something like a bathroom scale, which isn't very accurate. Now, this person here stands on the scale, and you can see the red digits here are the kilograms, okay, and you can see they only go up by increments of, it looks like, 1 kilogram, right? So at best, let's say I put an object on here that was 5 kilograms, or in other words, that's the same as 5,000 grams. So I put an object on here, and the thing goes up to 5 right here, and I would say, okay, well, that's 5,000 grams, right? And I would write it out like this, 5,000 grams. Now, if I put that same object on let's say an accurate digital scale, that could measure as accurately as a gram, where the last digit that it could measure was 1 gram, it could also say 500 grams. But the difference is very big. Okay, so even though the numbers are the same, 500, 500, this is saying I know that this digit right here is 5 because it's 5 kilograms. But you know what? I don't really know what this digit and this digit and this digit is. It actually could be 1 and then 0 and then 3 or something, but it doesn't know because the instrument doesn't have the ability to actually measure that accurately. It can only measure in the grams area, in the kilograms or thousands of grams place. It can't measure these because it doesn't have the ability to measure individual grams. This device, however, does. So when it says 5 and then 0, 0, 0, it's saying, no, I know this is a 5, and I know this is a 0, and I know this is a 0, and I know this is a 0. It's not that it's ambiguous, and I just have to put these zeros here as placeholders so that it's 5,000 instead of just 5. It's, I actually know the numbers. Here, we just put these zeros because I need this to be 5,000, right? And so I got to have some zeros there, and I don't really know what the numbers are. So we would say this has 1 significant digit, while this one has 4. 1, 2, 3, 4, because I know all of these numbers. They're all significant, meaning like they have meaning to them. I know what they actually are. So let's go through the rules of identifying how many sig figs, and we'll just go one at a time, and we'll show a bunch of examples of numbers. The first rule is that all non-zero numbers are significant. They're easy. The only problem is the zeros. Those are the only times where we really have to think and say, wait, is that 0 significant or not? If it's a non-zero number, it's automatically significant. So all these example numbers here, right, this one, that one, that one, that one, it doesn't matter how you write these numbers, they all have 3 significant figures. The second rule is that a 0 in between 2 numbers is also significant. So every single one of these numbers, okay, has 4 sig figs. If the 0 comes in front of any numbers, however, they're called leading zeros, and they are never significant. For example, this one here, 00351, only has 1, 2, 3 significant figures. These 2 are not significant. Now, of course they're not significant. In fact, we would never even write this number like this. We'd just drop the zeros. Why do we drop them? Because they're not significant. Over here, a number like this, it also only has 3 sig figs, 1, 2, 3. This 0 and this 0, they're not significant. We still have to leave them there so that we can put this 3 in the in the hundredths place, because that's the number. However, this 0 is just a placeholder. It's just getting that 3 in the right location. Same with all these zeros. They're non-significant. They're just placeholders. So 3, 5, 1. Those are the only 3 sig figs in this number, and that number. Trailing zeros is the case where it's a giant pain in the butt. Now there is a rule to follow, but it can get a little hairy. So the reason why is because trailing zeros can often be ambiguous. Sometimes they are significant, sometimes they aren't. The general rule of thumb is if there are trailing zeros and there is a decimal point in your number, then they are significant. If there is not a decimal point, then they are not significant. So here's an example. 351000. No decimal point. These are not significant. Or sorry, the zeros are not significant. The 351 are. So this only has 3 sig figs. 35100.0, however, has a decimal point, and that makes all of these significant. All the zeros and the 3's here are significant. 35100.0 has 6 sig figs. Now, the thing about this is, why would you put a 0.0 unless you actually knew what this value was? If you were just trying to say 35,100, right, and you didn't actually know this zero or that zero, that you just wouldn't bother with the point and you would drop that zero there. If you put a point and a zero, you're saying, wow, no, I actually know what this, I know what this is, and I know what this is. You're bothering to actually state what it is. You must know what it is. Same thing with a number like this, where it's 0.351000. If you didn't know these values were actually truly zero, you would just never say those numbers, and you would just say 0.351. Okay? If you're bothering to take the time to write them out, you must know what they are, and therefore they are significant. Let's talk a little bit more about trailing zeros, and this is the part where it really gets frustrating. So remember, in our first example, we said, hey, look, you measured the same object with 2 different scales. One was 5,000, the other one said 5,000, but one had 1 sig fig. The 5 was known, right, on the big bathroom scale. The 5 was known, and the other 3 zeros were not. On the digital scale, though, the 5 and the 3 zeros were known. So how do you know in a number whether those zeros are truly significant, like you know they're actually zero, or you just don't know and they're just placeholders? Well, the way we do that is we put a decimal point. So 351,000, 3 sig figs, no decimal point. The zeros don't count. Okay, 351,000 decimal point, that says that you know what these 3 numbers are. So the rule still holds from before, that if there's a decimal point, then trailing zeros are significant. The rule is still the same. So that makes all 3 of these significant. The weird and frustrating case is, what if you know this number 3, you know this number 5, you know this number 1, you know this number is 0, you know this number is 0, but you don't know the last number. Like your instrument is unable to tell you what this last digit is. You can't put a period here because that would make all the zeros significant. So 6 sig figs here. You're only supposed to have 5, right? How do you notate that? We do that by underlining the last significant digit. We rarely have to do this. This is rarely a problem, but when you need it, you need it. So this number down here has 5 sig figs. 35100 are all significant. We underline the last sig fig, and that means that this digit here is not significant.